Hi, today I'm gonna start my first um, math video about interview questions. So this one is called Gambler's Ruin. So, so basically the question or the setup is this. So basically you flip you play a game with another opponent, and each time you flip a coin and say you and your opponent each have 50% win in this flip, and so after this flip the loser transfer 1 penny or to the winner, and you go on the next round, and the whole game finish when one of the players won all the money. So now let's say if you have 3 pennies and your friend has 5 pennies to start with, so what is the probability that you win the whole game in the end? So you can probably take a few minutes to think of a strategy or the solution, and so So basically, I would like to, before I give the solution, I would like to give some analysis first. So obviously, when you think of the game, you say you have three to start with. Your friend has five. Now the first round, if you win, then you have 4 pennies, and your friend have 4 pennies. And this is an interesting point because once if you have 4 pennies and your friend have 4 pennies, and as you basically you have equal amount of money to start with, and then naturally you would think at that point you will have half chance to win the whole game in the end, because you and your friend have the same money to start with. By symmetry, each of you should just have half of the chance to finish the whole game. Now, but if you lose, then you will have 2 pennies, and your friend will have 6 pennies, and then it brings a new question. So if you start with 2 pennies and your friend has 6 pennies, what's the probability that you will win the game from there? And this question is just seems just as hard as the original question you have to start with. So then it kind of leads to nowhere, that because then based on the next game that you might get back to the 3 pennies, your friend back to 5 pennies, or you could lose another one that will end up you have 1 pennies and your friend have 7 pennies. Now that's another question. So it's kind of this kind of process can keeps going on, and then your money and your friend's money can go back and forth, and that is really the kind of the difficult part of this question. So so how do we solve that actually? um, so Well, the following is a typical strategy in solving this type of questions. So I would just uh, uh, I would just introduce a function, say p of n is defined to be the probability probability you start with n, n pennies in this, and win the game. Above. So to be more accurate, this game, this n means you start with n pennies and win the game above, assuming the total of your money and your friend's money is 8. So the total of your money and your friend is 8. So this is what I assumed. So we are in the same setup. So the n. So now we can have the next observation, which is so if you have n pennies in this setup, now the game you playing, you either will win 1 penny or will lose 1 penny with equal chance. So we would have this probably we would have this equation. So what does this equation mean? This equation means the probability you start with n and win the game is half of the time your next status will be you have won the first game, so you have n plus 1 to continue with, or you will lose the first round and you will have 1 less to continue with. And those two states have the equal probability you will transit from your current status to those status. And to win the whole game, of course, you in each those situation you would have to win from there. So this really is saying, depends on the result of first game, I could have started with n plus 1 and win from there, or I could actually end up with n minus 1 and win from there. So the total probability you start from the original n is going to be half of the time you come from the n plus 1 case and half of the time of n minus 1 case. So now, of course, we could continue writing this to more terms. So you can try. I'm just going to try show one more. So then you could say, okay, I will go with, by the same argument, I would have this. So I'm just applying the same recursion formula. Right, but then now this gets a little bit complicated. I mean, so far is not so complicated. It's just a little bit more complicated than the first one. I mean, you could try, if you do a little bit simplification, you will get something like this. Well, you can do another kind of simplification. Well, etc., etc. So you will get something, but does this really help? Because you can continue to write down this into more terms and, involving Pn plus 3, blah, 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 blah. Well, it doesn't really show a solution yet. I mean, we can build up these equations. So how do we, so maybe this is not the best way of expanding the whole thing. So let's park this complicated equation. Let's look back at this this original equation we have. And clearly, so let's first look at some special case. So if you start with 8 pennies, well, if you start with 8 pennies and your friend will have no pennies, so you surely have won the game. So that probability is 1. Now, if you start with no pennies, you start with nothing, and of course you have already lost the game, so you have 0. Now, so basically we are trying to identify what the function will look like if it satisfies these 3 conditions. So at one end you have 1, one end you have 0, and at every end this value is half of its neighbors, surrounding neighbors. And a quick, so what does this remind you? If you think of a linear function, if you have a linear function, the linear function has the natural probability that this point is naturally the mid of the surrounding neighbors. So a linear solution will satisfy this constraints. So of course, to give a more mathematical proof, it requires more, but for the sake of identifying the number, the final answer, you could go with, say, okay, P is a linear function. So Pn is a linear function of n. And then with that, then P3, which is the equations you have, which is the conditions you had, is then equals to 3 out of 8. So that means you have 3 out of 8 probability of winning the game, and your friend would have 5 over 8 probability winning the game. So if you started with 4, your friend started with 4, you will have 4 out of 8, which is half of the chance winning the game, which matches the intuition that you and your friend have equal money to start with. So there is no preference on which one you win in the game. So I will, if you are interested in so that's a solution for this problem. But I will leave more rigorous proof to prove that P is a linear function of n. To if you have for more interest, probably there is some I can give more explanation of that. But for the sake of solving the problem, that solves the problem. So okay. Thanks. This is my first time making the video. I hope you like it, and I will make more focusing on interview math questions.